Example 1 says, for each of the following, part A, show that the function f satisfied the hypothesis of the mean value theorem on the given interval close a to b close. Part B says, find the value c in between a and b that satisfies your equation f prime of c equals f of b minus f of a divided by b minus a. Remember, the mean value theorem says there are three things that we have to meet, right? It has to be if the function is continuous between a to b, in this case, our a to b is 0 to 1 and close, and then if it's differentiable between 0 to 1, non-inclusive, then we are going to guarantee to have at least one c value that will be parallel to the segment a to b, okay, or the line a to b. Okay, so condition number 1, let's see if we meet, okay? Part A, to meet or to satisfy the mean value theorem, we have to check, is the function closed from 0 to 1, a to b. Now your function is f of x equals x to the power of 2/3. This, students, is the same as y equals, or f of x equals, cube root of x squared. Okay, this is definitely continuous from 0 to 1. Okay, now is it close? Definitely close based on the given notation, so check on that. Now the third one that we have to meet is differentiable. It has to be differentiable over the open interval 0 to 1. Now, as you can see here, students, this is a parent function, so there's no translation left or right. Now, if we have a translation left or right, then that will be an issue at that location. But remember, 0 is not inclusive anyway, so this is definitely going to be differentiable from 0 to 1, non-inclusive. Now, part B said, okay, if it satisfies the mean value theorem, then find the value of c. Okay, so we want it to find all c's in between a and b that will meet this. This equation means, the derivative at c should be the same as your algebra 1 slope that runs through a to b. So we can do the right side first, okay? F of 1 minus f of 0 all over b is going to be 1 minus a is going to be 0. Now f prime at c, we can just do the derivative of this, okay? So f prime of x, and then we can plug in your c value later. Or we can find that later. So f prime, I'm going to use the power rule, so it's going to be 2/3 drop down times x. We are going to minus 1 from the power, so that's going to be a negative 1/3. This f of 1 to the power of 2/3, guys, is going to be 1. 0 to the 2/3 is 0. Well, actually, we don't need that, right? So it's really 1/1. Now, we don't have to technically substitute c in for x, okay? But in this case, I'm going to do it just so you guys can see what's happening. So this is going to be when x equal to c. We're trying to solve for c, okay? So it's going to be 2/3, and I'm solving for c, so that's going to be c to the power of 1/3 equals to 1. And this is the same thing as 2/3, and then this could be rewritten as a cube root of c. Whoa, I just dropped my pen and I erase all of that. Okay, cube root of c equals to 1. Multiply both sides, guys, by the denominator, so that's going to be 2 equals 3 cube root of c. Divide both sides by 3, so 2/3 equals cube root of c. Now undo the third root by raising it to the third power, just like that. Okay, so this is 8/27 equals c, and we're going to box that up. That is the final answer. Let's try another one. in example B, okay? Same exact set of directions, but this time is giving us an f of x equals a natural log of x minus 1. Now keep in mind, students, natural log or log, the domain of this is that x could never ever be 0 and x could never ever be negative. So I'm gonna say bigger than 0, but x cannot be, actually x could be 1, because that's going to give us log of 1 is just going to be 0. So x just has to be positive. Okay. So we have to check 3 conditions, okay, to meet the mean value theorem. Condition number 1, is it going to be continuous on the close interval between 2 and 4. Now this function right here, students, the transformation of that is going to be a translation to the right by 1. So the domain of this is going to be from 1 to infinity. So we have from 2 to 4, so it's definitely continuous in that, okay? Is it going to be close interval? Based on the restriction that they gave us, bracket 2 to 4, that would definitely meet the criteria. Is it going to be differentiable? Okay, over the open interval 2 to 4. And the answer is going to be yes, because natural log or log, you can have a nice smooth curve over its domain. Since this is translation to the right, so your domain is going to be from 1 to infinity, from 2 to 4 open interval, that will be differentiable. So all 3 criteria we have met, so it will satisfy the mean value theorem. Okay, so check, check, and check. Part B, if it does meet it, then we have to find a C value. So f prime of that C value will be parallel, aka the same of f of B minus f of A, all divisible by B minus A. Okay, so let's plug it in. Here we go. So first we are going to do the derivative of the natural log. So f prime of x. Okay. F of B, your B value is 4, A value is 2, all over 4 minus 2. All right, f prime of x is the derivative of natural log, students, is going to be 1 over x minus 1. Technically, we would need to multiply by the derivative of the inner, by the chain rule, but derivative of x minus 1 is just going to be 1. So that's going to give us over here f of 4, so that's going to be natural log of 4 minus 1 is 3. F of 2, 2 minus 1 is going to be natural log of 1, all divisible by 2. I'm going to go over here to the right. I'm trying to fit it all in one screen for you guys. Okay, so this is now 1 over x. 1 over x minus 1 equals natural log of 3. Natural log of 1 is going to be 0, students, so we don't need to write that. So that's going to be over 2. We can cross multiply here. Okay. So that's going to be 2 equals x minus 1 times natural log of 3. Remember, natural log of 3, students, is a constant number. It's an irrational constant number, so we can divide both sides by natural log of 3. I don't have a calculator, and you don't need one. Just leave it as a natural log of 3. Lastly, we are going to add 1 to both sides. Okay, so x is going to come out to be not a very nice number, but that doesn't really matter. We can leave it in a natural log format. So that's what we have for x. Now, x is the same as c. So yes, you can technically, as you can see earlier, I substituted x with c, but in theory, you don't really have to, okay? So if you said, okay, well, that's the same as c, you can write x equals, or you can write c equal. So we have 1c value. This is the slope, okay? This slope will be the same as the slope of a line that runs through the 2 points A and B.